All right, so we are in chapter 5. We're just flying along. I think I have my geometry classes in chapter 8. You guys are in chapter 5. But we skipped a chapter in geometry, and it seems the chapters in this book are longer there's more sections in a chapter in this book than the other books, but that's okay. All right, everybody ready? So you're going to think you're back in geometry class when we first start some of this stuff. We are going to talk about, what is that thing? An angle. Remember that? All right, so this is an angle. Hope you at least knew that. If you didn't, I should probably just quit because I taught most of you guys in geometry. So this is an angle. So what's an angle made out of? It's made of these two things right here. What are these two things? All right, a line? What is it? Okay, they are sides, but if I just did this like this, what's that thing right there? Oh, I'm so disappointed. It's an arrow. I guess you could say it's an arrow. That's a better answer than hypotenuse. It's a what? It's a ray. It's a ray. This is a ray. What's different between a line and a ray? A line keeps going in what? Both directions. A ray has a what? What do we call that thing? It's an endpoint. It's an endpoint. I was going to say, he didn't even have me. And all the rest of you guys, most of you anyway, had me in geometry. All right, so that's an endpoint. That's a ray. Keeps on going that direction. So what's an angle made out of? Let's go back to that. Two what? Two rays, all right? And they both have a common endpoint, don't they? All right, both of these endpoints are the same point. All right, we have a name for that. What do we call that thing? A vertex. All right, so that's a vertex. We do call them sides. What we're doing right now, what we're going to be doing in a minute, well, in a few minutes, is we are going to talk about these two sides. This side right here is it's going to be horizontal, all right? You'll see what I'm talking about later. But this is called the initial side. All right, it's the side that you begin with, okay? And this is the one where you end. They call this the terminal side. Okay? So these are sides. So that's the terminal side, and this is the initial side. That's not something that we talked about in geometry, so that's kind of new. A lot of times, you would name this angle. Okay, that little arc right there represents the angle. If it's an unknown angle, what's a weird letter? That's not weird. X is not that weird. It's not in our alphabet. It's not in our alphabet. I guess you could call it that. They actually do use alpha a lot in here. What did I use for an unknown angle? No. That's like the change in something, right? The change in Y or the change in X. That's delta. Anybody remember? Nobody? Unknown angle looks like this. Anybody remember that? It's a theta. Yes, it's theta. Do you remember that? We did it in my class. You didn't remember, but I'm not offended. I'm a little offended. 2 years? Okay, I'll give it to you. So anyway, that's theta. This book does use alpha. Alpha kind of looks like this. If I try to draw it, I'm not that good at them. But anyway, something like that. It's kind of like it. It's basically, you've heard of alpha and omega, the beginning and the end. There's your biblical integration right there. All right, so alpha is the first letter of the Greek alphabet, and omega is the last letter of the Greek alphabet. You've heard that verse, right? I'm the alpha, Jesus said it. I'm the alpha and the omega, the beginning and the end. All right, that's why he said it, because it's the first letter of the Greek alphabet and the last letter of the Greek alphabet. All right, anyway, you will use, they do use alpha in the book a lot. Usually I would use theta, but you can use any letter. You could call it x if you wanted to, Hannah. That would be fine. All right. But that's what we're going to use. All right. So let's do this. We got some ideas there. Now let's see what we're going to be looking at for a while here. So I'm just going to make me a nice, I'll tell you what, I got one already. There it is right there. Look how pretty that is. All right. So let's use this. All right. And what we're going to do is we're going to draw some angles. And we're just going to talk about it a little bit. You know this is the x-axis, y-axis, correct? But here's what they do. They say that here's your origin, but if you go in this direction, they say that's the 0, you're going 0 degrees. Okay? All right, so the positive x-axis would be at 0 degrees. Now, if we go up to here, how many degrees is that up here? It's 90 degrees, yeah. Now, look which direction we're going. We're going clockwise or counterclockwise? Counterclockwise, okay? So when you go counterclockwise, you're going in the positive direction. Sounds weird, right? Counter seems like it would be the opposite, but this is how they do it. All right, so it's just some convention that somebody came up with. Not really sure if it's credit goes to like one person or several people came up with it. I don't know the history of it. Talk to Mr. Rao. Mr. Rao is actually teaching a history of math class at Delaware Valley. He actually came up with a class on his own. They asked him if he could teach something like that. He's like, oh, I'd love to. I love the history of math. To me, I don't really care that much about the history of math. But there's a few things. I think are important. All right. So watch. Let's keep going. So if I went up to here, that would be 90 degrees. What would it be right here? It'd be 180. And then down here, what would that be? What is it? 360 down here? I don't know if I've heard it. Say it louder. I'm going positive. I'm going in this direction. So it would be, all right, because this is 180 plus what? 90, right, is 270, all right? And then if I go all the way back around to where I started, where is that? That's 360. So 0 degrees is at the same place as 360 degrees. Everybody see that? All right, I could go the other way. Let's do this in a different color. Still be 0, right? But this time I'm going to go clockwise. So if I go to here, what would this be? And I'm going in the opposite direction. So it's not just 90, going in the opposite direction. So what do you think I could call this? Negative 90. That's right. Remember, going counterclockwise, right? Going up this way would be positive 90. Down here would be negative 90. All right? And then you could go around to here. This would be positive 180, or you could call it what? Negative 180. It's the same spot, isn't it? All right? It's just the direction you took to get there. That's what it is, okay? So we're at 180 right now. What if I went all the way to there? You could call this what? Negative 270. And you go all the way, if you go all the way around again, right there, where do you end up? So you could call this what? Negative 360 if you wanted to. Everybody with me? All right. Let's see. Do I want to get into the... We do this a little bit later, so I'll do this one more thing with this, and then we'll go to something different. Then we'll come back to this a little bit, okay? That's just how they do it in the book, so that's how I'll do it right here. Do you remember that initial side, terminal side thing? That's what we're going to talk about right now. I'm going to do 3 of these. Can I fit 3 of these on here? Right there. And, oh yeah. Perfect. All right, what I'm going to do is talk about certain angles in here. And I'm going to do this. I'm going to make this in red. So this would be my initial side of my angle. Okay, I'm going to put an angle in here. See how that red's right on top of there? All right, so that's my initial side. That's where I'm starting. All right, if you noticed, on all of these, where did I always start? I always started at that positive x-axis. Okay, that would be my initial side. So you could go counterclockwise or you could go clockwise, all right, depending on how you want to get to your angle, what you want to call it, and all that kind of stuff. So That's my initial side. If I put an angle, let's say about right there. Okay, see that? And let's say I made that 30 degrees from there to there. So what would it be? What would the angle be called? Let's get rid of that. But that's 30, okay? What would this angle be right there? What is it? Well, how many degrees? 100? 100? 120. Okay, I just couldn't hear you. I got this fan of the computer blowing in my ear. Well, it's not blowing in my ear, but I got it buzzing and I can't hear too well. So you got to speak up. So this would be what? 120 degrees. Going counterclockwise, right? And that's usually the way we go, but we could go the other way too. So since we did blue before, let's stick with that. Or you could go this way, couldn't you? So what would that be? Well, you went to here, which would be what? 180. What's this part right there? Remember I said this little bit was 30. So what's this little bit right here? 60. So what would I do? You go 180 plus 60, which is what? So 240. So this could be at 120, and it could be at 240. Negative 240. Sorry about that. That's negative 240 because I'm going clockwise. Make sense? So instead of putting that 120 right there, it might be better if I put it right here. So that spot, that angle right there, you could refer to it as two different things. It could be positive 120, or it could be negative 240 degrees. We good so far? Yeah, it's not too bad. Let's do another one. By the way, this is our initial side. What would this side be considered? The terminal side, okay? Because this is where we start, this is where we end up, all right? Let's do another one. Again, there's my initial side right there. Okay, and let's see which way they want to go. Let's go about right there. And again, this little angle will make that 30 degrees, okay? I just won't write it in there because it just gets kind of messy. So make that 30 degrees. So let's figure out, where are we? Where's our location right here? We always start here, so we could do it two ways. Let's stick with the red and go counterclockwise. So we could go this way. So where would that be? 180 plus what? 60, right? Which is 240. So it's a positive 240. Yeah? Okay, or I could go the other way. I could go from here to here. Yeah? Everybody see that? So I went 90. Remember that little angle I said was 30? So 90 and 30 is 120, but it's what? I went in the clockwise direction, so that would be negative 120 degrees. We good? Yeah. I have a third one in there, but I just made it at 90. It's not that big of a deal. I'll put a red one go this way and a red one this way, and that's 90. I don't need to draw that out. All right, let's get to something that I hardly ever use. I mean, I know what they are, but people use it all the time. I don't know. When you think of GPS, you're just thinking, oh, the little lady on there tells me turn right, turn left, you know, how far I got to go and all that kind of stuff, okay? But GPS is based on different measurements, different degrees, and things like that. So degrees isn't the smallest. It's not really a unit of measure. I guess maybe you could consider that, but there are smaller units other than degrees. So if I had a whole entire circle, how many degrees is a whole entire circle? 360. Okay, everybody understands that, right? We kind of talked about it already. All right. So what if you had 1 degree? Here's what I read in the book. I read in the book if you had an an equilateral triangle. They talk about the ancient Babylonians and all this kind of stuff. There's the history again. I am a big history fan. But I just don't know a whole lot about math history. It's not that I'm not interested in it, just never studied it that much. But anyway, this guy in the book, or girl, whoever, was talking about an equilateral triangle. How many degrees, without me, this is equilateral, right? Boom, boom, boom. How many degrees are each of these angles right here? What's that? Well, if all the sides are equal, what's true about all the angles? They're equal, right? What do they all add up to be? No, it's not 360. It's a triangle. What do they add up to be? 180. Okay, so each angle is what? 60 degrees, all right? So they talk, you can read it, there's a paragraph in the book about the ancient, I think it's Babylonians, and they talk about their unit of measure was not based on hundreds like ours mostly is. It's not all the time because we got 12 inches in a foot, we got 3 feet in a yard, and all that weird stuff, all right? But if you talk metric system, our number system is all based on hundreds. Would you agree with that? All right. But they said back then they based it on 60s. Okay, and they based it because one of the angles, well, all three of the angles of an equilateral triangle is 60. So they based everything in 60s. All right, so 1 degree, if you went smaller than 1 degree, so let's just write this down there. So we have degrees and we have minutes. Have you ever heard of that? Not talking about minutes on a clock, like that kind of thing. But then they have seconds. I mean, it sounds like a clock, and the numbers kind of work out that way. But we also do it in measuring angles, right? If you want to get really specific, instead of like 27.345 degrees, they might say 23 degrees, so many minutes, so many seconds. All right. Have you ever seen that before? I don't know, maybe on a movie or a TV show or anything like that, on maps. You've never seen that? Like latitude and longitude. Have you heard those words before? Okay, if you look at latitude and longitude, a lot of times they'll do things in degrees, but when they want to get more specific than just a degree, instead of just a decimal point whatever, what they're going to do is change it to minutes and seconds. So a minute is 1/60th of a degree. So 1/60th of 1 degree. Okay, so they break that 1 degree. So think about it. If I had a protractor and I measured something and it was 1 degree, it would be pretty skinny, wouldn't it? All right. But if I broke that skinny little 1 degree angle down into 60 parts, each one of those parts would be a what? A minute. Okay. So then what about seconds? This is 1/60th. By the way, minutes, let's see how I wrote that. Yeah, so 1/60th of 1 degree, this is a times, that's a dot, okay? 1/60th of 1 minute of 1 degree, I'm getting ahead of myself, equals 1 minute. So a minute, we just use like a little, I don't know, what do you call it? Like an apostrophe kind of thing. It's not really apostrophe. I guess it could be. It's just a little slashy thing right there, okay? That means minute, all right? So instead of degrees, which is a little circle, that means a minute. What's 1 minute? It's 1/60th of a degree, all right? So what do you think a second is? That would be 1/60th of a minute, okay? So 1/60th of a minute is 1 second, and a second is like a double slashy thing. It's kind of like on your computer keyboard, right? When you have a quotation mark, right? The 2 little things. All right, that's kind of what that is. What if I had 1 degree? So like 1 second is equal to how much of 1 degree? Well, it's 1/60th of a minute, and a minute is 1/60th of a degree. So what is 1 second? 1 second would be 1 out of how much? That's it, 3,600 degrees. Okay? Is that right? I should write it like this. 1/36 of 1 degree. There you go. Does that make any sense? So these are small little things that are going to be very, very hard to measure. But if you want to get precise, 1 degree could be pretty wide depending on how big your circle is, okay? If your circle is really big, okay, then 1 degree gets bigger and bigger and bigger, doesn't it? Compared to if you had a little tiny circle. So if you think of the Earth, which is a pretty big circle, if you're of the type of people that think that it is a circle, some people think it's just completely flat, but you think it's flat? Sure you do. So anyway, it is a sphere. So anyway, 1 degree would be pretty big, right? But if we wanted to get it more narrow and more narrow, if we take that 1 degree, break it up into 60, that's 1 minute. If we break that 1 minute into 60, right, that would be 1 second. Okay? Make sense? Yeah, sure it does. All right, so here's what we're going to do. Let's do a couple examples. With that said, again, this is stuff that I don't really use that often, but there are people that do this stuff all the time, especially people that like make maps and try to figure out, I don't know, lots of stuff. There are people that do this kind of thing. So here's what we're going to do. We are going, this is example 1. We are going to change. Remember what I said earlier? Instead of like 23.724 degrees, we're going to put it 23 degrees, so many minutes, so many seconds. That's what we're going to do right now. Okay, so change, instead of 23, it's 15. 15.735 degrees to, and then we're going to go degrees, minutes, seconds. Okay? Again, you'll see this on maps, a lot of different maps and things like that. People don't use maps anymore, okay, because we got GPS. But this is what we're going to do. Yeah, you'll see that a lot. Exactly right. If you go to some place in the middle of the country somewhere, right, and there's no like landmarks or whatever, and you push Google Maps, it'll give you degrees and I believe it'll give you latitude, longitude, and it'll give you degrees, minutes, and seconds. All right, if you look at that, it'll give you these coordinates, right? These GPS coordinates. All right, so yeah, I mean, people use it all the time. So here's what we're going to do. We're going to go 15. So this would be 15 degrees. And this, we're going to break that up into minutes and seconds. All right. So first thing we're going to do is turn it into minutes. So we keep the 15 there, and then we're going to add it. Watch. It's 0.735 minutes. I want to make sure I do this right because, like I said, this is something I'm not that familiar with. So I just want to make sure I write this down and explain this correctly. So if this is 0.735, let's say it was 0.5. Let's make it easy, and then we'll figure out how to do the 0.735. Let's say it was 0.5. What would that mean? It'd mean half a what? Half a degree, right? 15.5 degrees. That 0.5 represents what? Half a degree. Understand? So how many minutes would that be? Half a degree. Remember, you broke that degree into 60. So what's half a 60? Be 30. So it would be 30 minutes. Make sense? Okay. So, but it's not a half. It's 0.735. It's a weirder number. But what do? We take that 0.735 and multiply it by 60, and that will give me how many minutes this is. Okay? And that would give you, I'll just write it down. So that's still 15 degrees. And if you do this math right there, it's 44.1. So that's 44.1 minutes. Okay? Remember, this is bigger than a half. What was half a degree? It was 30 minutes, wasn't it? So this is a little bit bigger, so that's going to be bigger than 30. You get that? Okay. So now we got minutes. Now we got to change this into seconds, or that 0.1. See that 0.1 right there? We don't want a decimal. We want to know how many seconds is that going to be. So we are going to take, we got the 15 degrees, we got the 44 minutes plus. Now I got to change that 0.1 into seconds. How am I going to do that? Well, I'm going to take that 0.1 and multiply it by what? How many seconds in a minute? 60, right? And that's going to give me how many seconds? All right, you should be able to do this in your head. Times 0.1, which way would you move the decimal? To the left one place? Yes? All right, so you can put in a calculator if you wanted to. So now, what do we got? We got 15 degrees, we got 44 minutes, and then we got what? 6 seconds. So that right there means the same thing as that right there. We just got a lot more specific with our degrees. Is that the first time you've ever heard anything about minutes and seconds? With as far as degrees, not a clock and not time, right? This is kind of more of a measurement, not of time, but of angles. It's a measurement of angles is exactly what it is. It's just real specific, really specific. Okay? So now when you punch something in GPS and you see that, and you're like, oh, I kind of have an idea what that means. Let's do another example and then we'll quit. Everybody write that down? If not, watch it on the YouTubes. All right, now we're going to go the other way. So this time, they're going to give it to you in degrees, minutes, and seconds, and we're going to change it to a decimal. All right? So here we go. What do they give you? 39 degrees, 5 minutes, and then 34 seconds. And we're going to change that into a decimal. All right, basically, we already got the 39. You know it's going to be 39 point something. Okay, so this right here is going to be a decimal. And it says to round it to the nearest thousandth place. How many decimal places is a thousandth? How about 3 decimal places? Look, here's your decimal. Oops. What's the first place value? That's the tenths. Then this is the hundredths, and this is the thousandth. Okay, so we're rounding it to this place right there, 3 decimal places. All right, so let's do this. So the 39 I can just keep by itself. I already got that, and I know it's going to be 39 point something. All right, now this is where it gets a little tricky. What we do is this, plus we got 5 minutes, and we multiply it, or actually, you could think of it as dividing, right? We're going the other way. Before we multiplied, didn't we? When I went from a decimal to the minutes. This time, if I'm going minutes to a decimal, I'm going to do the opposite. What's the opposite of multiplying? It's dividing. What they did is they put it times 1 over 60, all right? And that's minutes. All right? So that's what we did to that. And then the seconds, watch this. We're going to take the 34. Now, this is 1/60th of a degree. But what fraction of a degree is seconds? It's not 1/60th, but 1 what? 3,600, right. Okay, and we put the seconds right there. So what you're going to do is you're going to put that in a calculator, okay? So we got 39 degrees plus, you do this multiplication right there, and let's see. I don't do it separately. I think I did it all at once. I was going to do it separately, but okay, so it's 39. Once you get this number, then you add it to this number, and then you're going to get 0.093. 0.093. Just do it in a calculator, okay? Figure out what that is, figure out what this is, add them up, round it to the 3rd decimal place, and you'll get 0.093. You already got your 39 degrees here, so put the degree symbol there. So 39.093 degrees is the same thing as 39 degrees, 5 minutes, 34 seconds. So when you're going from minutes and seconds, what do? You divide by, okay, so the minutes you divide by 60. With the seconds, you divide by 3,600. The degrees, you just keep what it is. And there you go. you have changed it from degrees, minutes, and seconds to a decimal. And it's all degrees. This is all degrees right here. I think after you get used to it, it's not that big of a deal. You just got to know when you multiply by 60, right? When do you do that? When you're changing from a decimal to minutes and seconds. If they give it to you in minutes and seconds, what do? You divide. So the minutes you divide by 60, the seconds you divide by 3,600. If you can keep that straight, you should be good to go. Make sense? All right. I got a lot more to talk about, so we'll end it there, and we'll continue after we take corrections sometime, okay? But keep that in your notes, and we'll get back to that sometime, probably next week, okay? All right, test tomorrow, remember that, and corrections on Friday.